In 1999, a team of Japanese researchers led by Masayasu Kojima were not looking for the reason you feel hungry. They were searching for a molecule that activates the growth hormone receptor. They sifted through extracts of rat stomachs, an unlikely place to look, and found something that did exactly that. It was a peptide, a small protein, and they had stumbled upon the primary signal that your stomach uses to tell your brain it's empty. They named it ghrelin. The name itself is a clue to its ancient origins. Gre is the Proto-Indo-European root word for to grow. This is because ghrelin's first known function was stimulating the pituitary gland to release growth hormone. The hunger aspect was almost a side effect, a secondary discovery. Your drive to eat is directly tied, by name and by chemistry, to your body's fundamental command to build and repair itself. So, where does this powerful signal come from? Not the whole stomach, but a specialized group of cells called PD-1 cells in humans or XA-like cells in rodents. These are endocrine cells, meaning your stomach isn't just a digestive sac, it's a gland. It's a chemical factory that broadcasts messages to your entire body. When your stomach has been empty for a while, these specific cells begin secreting ghrelin directly into your bloodstream. The journey for these molecules is a long one. They travel through your circulatory system, past organs and tissues, on a very specific mission. Their target is a region deep inside your brain called the hypothalamus, the master regulator of many of your body's basic functions. Specifically, ghrelin is aimed at the arcuate nucleus within the hypothalamus, a tiny but critical cluster of neurons that acts as the control center for appetite. Once ghrelin arrives, it binds to receptors on a specific set of neurons, the NPY/AGRP neurons. Think of it as a key fitting into a lock. This binding action essentially turns these neurons on. When activated, these neurons release chemicals that create the powerful, motivating sensation we call hunger. It's not just a feeling, it's a command to seek out and consume energy. But here is where it gets strange. You probably get hungry around the same times every day, even before your stomach is truly empty. That's because ghrelin release isn't just triggered by emptiness, it's scheduled. It operates on a circadian rhythm. Your body learns your meal times and begins to release ghrelin in anticipation of food. That 12 p.m. hunger pang is your brain's clock, not just your stomach's complaint. Ghrelin isn't shouting into a void. There is a constant chemical conversation happening. Its primary conversational partner is leptin. While ghrelin is a short-term signal from your empty stomach, leptin is a long-term signal released from your fat cells. Leptin essentially tells the brain, we have enough energy stored, you can stand down. Hunger is the result of the balance, or imbalance, between ghrelin's urgent eat now and leptin's calmer, we're okay for now. The effects of ghrelin don't stop at making your stomach rumble. It also acts on other brain regions, like the hippocampus and the ventral tegmental area. This means it can enhance your spatial memory, helping you remember where you found food before. It also boosts the reward circuitry, making the idea of food more pleasurable and motivating. It's not just a hunger molecule, it's a foraging molecule, optimizing your brain and body to succeed in finding fuel. But the bloodstream is slow. What happens when you eat? Your stomach has a direct, high-speed connection to the brain, the vagus nerve. As your stomach stretches with food, it sends a neural signal straight up the vagus nerve to your brainstem. This signal is much faster than waiting for ghrelin levels to drop. It's the immediate message received, you can stop eating signal that allows you to feel full long before your body has even started digesting the meal. This entire elegant system of signals and clocks evolved in an environment of food scarcity. Ghrelin was a survival tool. Today, however, it operates in a world of constant food availability. Highly palatable, energy-dense foods can affect the ghrelin-leptin conversation, sometimes leading to a system where the "eat now" signal becomes louder and more frequent than the "we're okay" signal. The emptiness signal now broadcasts into a world that is always full. Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.